Well, good afternoon, evening, everyone from Reno, Nevada. I'd like to introduce today's speaker. Her name is Sara. She is a Great Basin archaeologist, born and raised in Northern Nevada, Battleborn. She graduated with an MA from the University of Nevada, Reno in May of 2020. She's now an associate archaeologist with ASM affiliates in Reno. And Sara was part of a team that did some research at our Leonard Rock Shelter preserve. And she's here to tell you all about that research. So take it away, Sara. Thank you.
Thank you for coming to this virtual talk. As Gloria said, my name is Sara, and I will be discussing our research at Leonard Rock Shelter that I conducted with the Great Basin Paleoindian Research Unit, or GBPRU for short. And so Leonard Rock Shelter is located in the Humboldt Sink in Pershing County, Nevada, and it's located roughly here in this photo, and that's 27 kilometers south of Lovelock. And so the Humboldt Sink, it is a remnant of the old Lake Lahontan system in the Great Basin, and the shelter was originally thought to sit at 1,272.5 meters above sea level. And so Robert Heizer, he was an archaeologist from the University of California, Berkeley, and he excavated the site in 1950. And he reported more than 2 meters of stratified deposits, from which he recovered a modest assemblage of perishable and lithic artifacts. So of interest to the GBPRU was Heizer's discovery of these obsidian flakes, or this volcanic glass, in deposits that could date anywhere between 14,900 to 11,600 years ago. So for those of you who are not familiar, a flake is just simply a portion of a rock that a human has removed during the process of making a stone tool. And so this possibility of a stratified Pleistocene occupation prompted the GBPRU to return to the rock shelter in 2018 and 2019 for additional work. And so this produced only a few artifacts, but a really sizable small mammal assemblage. And so this talk is twofold. First, I'm going to discuss our findings from our excavations and some radiocarbon dates that we received. And then I'm going to discuss my analysis of the small mammal assemblage at the site. And so here's where Leonard Rock Shelter is located in western Nevada, with the Humboldt Sink to the north and the Carson Sink to the south. And so you'll hear me talk a lot about Lake Lahontan in this presentation. And so Lake Lahontan is just simply a Pleistocene-aged lake that occurred over much of western Nevada, as you can see from this picture. And it's not particularly applicable to this presentation, but Lake Ronneville, it was a Pleistocene lake that was located in the eastern Great Basin. And then that's roughly where Leonard Rock Shelter is located within this Lake Lahontan system. So before we dive right into the research, I'm going to provide some background information on the region throughout the terminal Pleistocene and the Holocene. Now these terms, Pleistocene and Holocene, these are just geological time periods. And so the terminal Pleistocene and early Holocene, when I'm saying that, I'm really just talking about this time period between 16,000 and 8,300 years ago. So first I'll talk about the environment during this time. So during this time, lakes were generally higher than at any time after. And there are these two notable high stands. They were called the Seeho and the Younger Dryas. And the Younger Dryas high stand will be important later in my discussion. And we're also seeing that along the middle Humboldt River, it's showing a more mesic. And when I see mesic, I just mean cooler, moist conditions during this time period. And then we see that the pollen record is also showing these higher pine and sagebrush levels, which can also be interpreted as a more cooler, moist, or mesic times. And there's declining numbers of these during the early Holocene, but they're still relatively higher than at any time after. Now, if we look at the archaeological sites, especially for the terminal Pleistocene, there's really only a few of them, and the majority of the dates in these artifacts have been up for debate. So if we look at Fishbone Cave, that dates to around 13,000 years ago, and it's got these two horse mandibles with human modification. However, not all archaeologists agree that this modification is cultural. And then if we move on to Handprint Cave, there's this terminal Pleistocene date on some charcoal that was found beneath a Western Stem Tradition projectile point, which is this really old projectile point. However, a lot of archaeologists believe that it is a much younger Humboldt point that dates kind of to the middle Holocene to late Holocene. And then if we look at Pyramid Lake, there are these two bone points. And these bone points are likely made of mammoth ivory, but their points, they date to the age of the death of the animal and not when the points were actually used. And then at Leonard Rock Shelter, of course, we have that date on some back guano with some associated with obsidian flakes that's dating to that terminal Pleistocene. But then as we move on to the early Holocene, sites are a little more common. So at Spirit Cave, there's 5 human burials, 2 cremations, and around 70 artifacts recovered. And it's best known for the Spirit Cave mummy, which dates to around 10,500 years ago. And it was also associated with these finely decorated textiles. And the fecal boluses from the mummy suggest that his last meal included small fish and bulrush seeds. And then if we move to Grimes Burial Cave, we see that it contained a plain leaf mat that dated to around 10,800 years ago. And then if we look at Horse Cave, there's also some textiles that date to around 9,400 years ago. There's this really lovely piece of warp-faced plain weave basketry from Hidden Cave that dates to around 10,400 years ago. And then if we look at these open air sites called the Sandmat and the Coleman sites, these both served as retooling stations, or to word that differently, just a place where humans would resupply their stone tools. And then there are some artifacts and human remains from Wizard's Beach that date to the early Holocene, indicating that groups would use sagebrush cordage and bone tools for fishing, but there really is no evidence that they were associated with the habitation site. So like most early sites, these locations likely served as short-term stopovers, where these mobile groups, they would exploit these marsh resources rather than living in these long-term residential camps. So if we move on to the Middle Holocene, archaeologists have just placed that between 8,300 and 5,100 years ago. In the environment, we see that this is really a xeric or hot and dry time. So we see as much as 2 squared kilometers of sediment deflating from the Carson Sink, which is signaling a time of drying. And it's really unknown how much deflation took place in the Humboldt Sink, but we do know that there's this windblown silt and Leonard Rock Shelter, and that's evidence for deflation as well. And then if we look at Winnemucca and Pyramid Lakes, we see that these lake levels are decreasing, signaling also a drier and warmer time. And actually the driest period along the Humboldt River began 7,600 years ago, with only a minimal amount of floodplain aggregation at 6,300 years ago. And then if we look at the pollen record from Hidden Cave, Leonard Rock Shelter, and Pyramid Lake, it's showing this rise in Kino-am, or these plants that are just more adapted to these hot and dry climates. So particularly in the Great Basin, a good example of a Kino-am plant is like a shad scale plant. And so as far as archaeology goes, it appears that at least this area of the Great Basin was largely abandoned during this time. At Hidden Cave, we see that there's some burnt organic debris that could date between 6,200 and 5,900 years ago. And at Leonard Rock Shelter, there was this infant burial that was associated with some carbonized basketry, and that could date anywhere between 7,600 and 5,900 years ago. But that's really all the evidence of human occupation that we have for this time period. So then as we move on to the late Holocene, archaeologists have placed this between 5,100 and 150 years ago. And so the environment, it's best characterized as a more variable climate with these numerous wet and dry periods. And we see that the lake levels are demonstrating these recurrent droughts. But we do know that there was a relatively wet period known as the Neopoluvial period that occurred between 4,800 and 3,400 years ago. And then some coprolites from Hidden Cave are also supporting that there was another wet period between 1,800 and 1,400 years ago, as people were visiting Hidden Cave more during this time. And then the Pyramid Lake pollen, it's showing these wet and dry phases beginning at the beginning of the late Holocene, with 18 wet and dry oscillations occurring in just the past 2,500 years ago. And then along the Middle Humboldt River, we see increased fluvial activity, but there's also these periods of floodplain abandonment. So this is just a really variable time climatically. And so then as we move on to the sites, we see that there's a lot more sites to date to this period. So in this region, we have cave sites such as Lovelock Cave, Humboldt Cave, Hidden Cave, and then of course Leonard Rock Shelter. And then we have these open air sites called the Humboldt Lake and Stillwater Marsh. And so a really important thing I want to bring up now, and it's been found at Lovelock Cave and Humboldt Cave, is this thing archaeologists call Lovelock culture. And so these artifacts include this really particular type of basketry. It's Lovelock wickerware with these large mortars, biconical pestles, these L-shaped scapula owls, Thule duck decoys, and zoomorphic figurines. And so duck decoys, those are a well-known component of the Lovelock culture, and they're signaling this reliance on wetland resources. And so as we move into the late Holocene, we see greater population densities in the region. So these two researchers, Heizer, who excavated Leonard Rock Shelter, and Thomas, they came up with these two differing theories about settlement strategies, or to put it another way, where people were living and why they were living there during this time. And so Heizer argued for the limno-sedentary model, arguing that groups were tethered to these wetland resources, while Thomas argued quite the opposite. It was this limno-mobile argument, saying that groups only use wetlands short term. However, today we understand that the evidence is really not wholly consistent with either a fully sedentary or fully mobile lifeway. And we also understand that caves generally lack fire pits and large quantities of waste, or those flakes, due to stone tool production, suggesting that groups did not live in those places for extended periods. Instead, sites such as Lovelock Cave, Leonard Rock Shelter, Humboldt Cave, and Hidden Cave, those seem to serve as places to cache their fishing and hunting gear for future use. And they would also cache those things like those duck decoys that we see from the Lovelock culture. And so we can best understand where people were living during this time by comparing this open air record to this cave and rock shelter record. And so the Humboldt Lakebed site, it's located in the Humboldt Sink, just north of Leonard Rock Shelter, Lovelock Cave, and Humboldt Cave. And so we know that groups used Lovelock Cave for caching before they intensively occupied the Humboldt Lakebed site. And so this lag is likely reflecting a more sporadic use of wetlands before 1300 years ago. And we know that the site at least saw intermittent use until 5,500 years ago. In the lakebed site, it was primarily a residential locus, whereas the cave, that would serve as the storage facility or this cold weather retreat, even a burial locale or a place of possible ceremonial activities. And just south of the Humboldt Range in the Carson Sink is the Stillwater Marsh. And here, groups exploited the marsh resources when they were available, and they occupied wetlands for at least part of the year. There was cached duck decoys, fish hooks, and items used to harvest wetland resources that are showing this commitment to marshes. However, the very act of caching this gear also suggests that there was at least periodic or seasonal abandonment of such places. And so Robert Kelly, he's a really well-known archaeologist, he's arguing that groups around these marshlands, they were more sedentary around them in times of drought. And when the marsh was inundated, the marshes actually aren't as productive, and that's when we see them visiting Hidden Cave more. And so now that we have some background on the region, both the environment and the archaeology, we can jump into Heizer's excavations at Leonard Rock Shelter. And so in 1938, there were actually guano miners at the shelter, and they recovered an adult dirt and a string of olivella shell beads. And these olivella shell beads, they originate along the coast of northern and central California, which is signaling that Great Basin groups were likely trading with these coastal California groups, or there was at least a system in place where these beads could somehow end up in the Great Basin. And so this prompted a small crew from the University of California, Berkeley to visit the site, and they also recovered a blade fragment and 3 foreshafts. And so in 1949, with the advent of radiocarbon dating, Heiser submitted some back guano and some adult foreshafts for dating. And those return dates of around 11,000 to 8,300 years ago for the back guano, and around 8,600 to 7,200 years ago for the adult foreshafts. And so radiocarbon dating, that's just a method for determining the age of an object that contains organic material by using properties of radiocarbon, which is just a radioactive isotope of carbon. So radiocarbon dating can only be done on organic material. So given the antiquity of these dates, Heiser brought a crew to the rock shelter for formal excavations in 1950. And so they excavated 4 areas, and they labeled them A through D. And like I said, they reported more than 2 meters of stratified deposits, from which they recovered this modest artifact assemblage of textiles, cordage, there was 2 projectile points, a tanflint blade, 2 flakes, 2 olivella shell beads, a foreshaft, fragments of cane and arrow shafts, and desiccated fish and pine nut shells. And they also recovered an infant burial from Area C, and that can date anywhere between 7,600 and 5,900 years ago. And then, of course, they submitted that back guano that was associated with those obsidian flakes that I talked about at the beginning of this presentation that are suggestive of this terminal Pleistocene occupation. And so here's just a plan view of Heiser's excavations. You can see actually only area B through D is on this slide. However, area A would have been to the left or to the east of area B. However, that area was very unproductive. And so here's just some pictures from their 1950 excavations. So this is actually this calciferous tufa that has been deposited on the rock shelter wall during one of the high stands of Lake Lahain. You can actually see there's even some portions of the rock shelter where it's fallen off. And then there's some petroglyphs in the background. And here's just another photo of their 1950 excavations. They're digging really deep under the rock shelter wall in area C, and this is that calciferous tufa with these petroglyphs in the background. And so here's Heiser's stratigraphy from his 1950 excavations. He identified 5 stratigraphic units, and he labeled them A through E. And so based on the radiocarbon dates and the artifacts that he recovered from these stratigraphic units, he argued that Unit A could date anywhere between 5,000 years ago to Euro-American contact. He also argued that Unit B could date anywhere between 7,400 and 5,100 years ago. There were no artifacts or radiocarbon dates from Unit C, so he really couldn't infer what that time range could look like. And then for Unit D, he was arguing that that could date anywhere between 14,900 years ago to 7,200 years ago. And the most important stratigraphic unit, to me at least, is this Unit E, which contains this angular rock in this Lahontan beach gravel. And so these beach gravels were deposited in the shelter during the last high stand of Lake Lahontan. And these beach gravels are going to be important later in my presentation. So when we returned to Leonard Rock Shelter, we were attempting to locate an intact profile from Heiser's 1950 excavations in order to get a better idea of his stratigraphic units that he defined. So we established a 1-meter grid across Heiser's area B in an attempt to locate that profile. And we excavated 3 1-by-1-meter test units. 2 were excavated arbitrarily in the summer of 2018, and 1 was excavated in 5-centimeter levels in the summer of 2019. So there were 2 units, Northern 495 Easting 500 and Northern 494 Easting 500, and they cross-cut the eastern profile of Heiser's Unit 3 Trench B in his Area B. And so the sediment in the eastern section of these units, it was disturbed, so we had to screen it separately. And you can see from the photo here that intact deposits are these lighter ones to the left, and these disturbed deposits are these darker ones to the right. And so here is that 1950 trench that we actually cross-cut during our 2018 and 2019 excavations. And so here are the strata of the 3 units that we excavated, and here are all of the radiocarbon dates that we received off of organic material that we would find while we were excavating. You'll see that these radiocarbon dates in red are erroneous or they're incorrect, meaning that these are likely disturbed deposits as well. And this radiocarbon date down here, that's actually not a radiocarbon date, that is Mount Mazama tephra, or volcanic ash. So when Mount Mazama erupted, it deposited a large amount of volcanic ash over the region. And so when we were excavating Leonard Rock Shelter, we came across this ash in our unit, and you can tell because it kind of looks different from the other sediment that you're excavating. So we took a small sample of it and we submitted it to a lab, and they were able to tell us, like, yes, this volcanic ash came from the eruption of Mount Mazama. And we know when Mount Mazama erupted around 7,600 years ago. And so we defined 9-meter strata in the same area where Heiser defined 5. And so correlating these sequences proved to be challenging. I'm confident that Heiser's Unit E correlates to our stratum 9 because those are both those beach gravels. I'm also confident that our stratum 1, which is described as poorly sorted gravelly silt, correlates to Heiser's Unit A, which is described as windblown sand and silt, with tufa, rockfall, back guano, and pack rat nest material. However, I had to loosely correlate the remaining strata just based on Heiser's descriptions. However, By looking at photos of Heiser's excavations that were on file at Berkeley, we realized that over the course of our excavations that his crew actually removed the top 75 centimeters of deposits where we placed our units, Northing 495 Easting 500 and Northing 494 Easting 500, during their 1950 excavations. So we did this by using a large crack in the rock shelter's tufa-covered wall, which is visible in this photograph, as a guide. So we located the approximate elevation of the top of the shelter's deposits, and we found that they sat at 100.41, or 41 centimeters above where we placed our datum. And so when we began excavating the surface of Northing 495 Easting 500, it was at 99.65 meters. And the surface of Northing 494 Easting 500 was at 99.75. And so this up to 75 centimeter difference means that our stratum 1 is a truncated version of Heiser's Unit A, and that our excavations likely did not encounter many late Holocene deposits. And so let's move on to the artifacts that we recovered. So like I said, we really didn't recover that many artifacts, and there were several modern items such as metal wire and shell casing. And however, unfortunately, all of the olive beads that we found were from disturbed surface deposits. However, there were several flakes that were found in stratified context, and the most notable find is this biface pictured here on the right. And so this biface is made of obsidian or volcanic glass. And you can actually source obsidian to figure out where it's from, because each obsidian source around the globe, it's going to have a different geochemical profile. So we were able to source this biface, and we found that it's made of Boardwell Spring, Pinto Peak, Fox Mountain obsidian. And so this particular obsidian can be found in northwestern Nevada, roughly 180 kilometers from the rock shelter. And we have a radiocarbon date from the stratum from which we recovered this biface from, and the stratum dates to around 11,200 years ago. So this suggests that the biface is quite old. However, it doesn't appear to be a projectile point, but regardless, the association between this biface and the date indicates that groups visited the rock shelter during the early Holocene, and it solidifies the rock shelter's position on the list of archaeological sites that immediately post-date the Younger Dryas in the Lahontan Basin. So another important find through our excavations was actually the elevation, because the elevation of the rock shelter and the presence of these Lahontan gravels in the shelter are critical to our understanding of when humans could have first occupied this site. And so Heiser reported that early date of 14,900 to 11,600 years ago that was associated with those obsidian flakes. And that suggests that the initial occupation might be among the oldest in the Great Basin. And so based on his understanding of the elevation of the rock shelter, which he thought was at 1,272.5 meters above sea level, and what was known in the mid-20th century about Lake Lahontan's history, Heiser concluded that the site was likely dry and available for occupation as early as 13,000 years ago. Or to put it another way, Heiser thought that after 13,000 years ago, the lake never again flooded the site. However, with the help of Dr. Ken Adams from the Desert Research Institute, we re-recorded the elevation of the shelter, and we found that it actually sits at 1,224.5 meters above sea level, so this green line right here. And so you can see how that's significant. This gray area, that's signaling the Younger Dryas. And so it's significant because based on what we know about Lake Lahontan's history and that date of 11,200 years ago that we obtained on that charcoal that's sitting immediately above those rounded gravels in stratum 9, it's clear that those lake gravels, they were deposited during the Younger Dryas that I spoke of earlier at the beginning of this presentation, and not an earlier Heistein lake, the Seeho. And so we now know that Heiser's interpretations are based on an incorrect elevation for the site, and that's really changed the likelihood that the site contains evidence of a terminal Pleistocene occupation. However, we did not reach bedrock in our excavation units, so we cannot rule out this possibility completely that the site contained evidence of a pre-Younger Dryas occupation. However, given that Lake Lahontan flooded the site after that time with enough force to deposit this large quantity of gravel, we suspect that if humans did visit the site before the Younger Dryas, any traces of such visits were destroyed by the lake. So you must be wondering, when is the small mammal assemblage going to come into play? Well, small mammal assemblages, they offer a really unique opportunity to understand environmental change because different taxa will have different ecological tolerances. So by looking at the different ecological tolerances of these small mammals and observing shifts in the diversity, abundances, richness, and evenness of the assemblages, researchers can identify these local environmental shifts. And so you've already heard me talk a little bit about mesic and xeric. Same thing applies for small mammals. So some small mammals are more mesic adapted or more cool and moist. And some small mammals are more xeric adapted or hot and dry. And these small mammals, they can provide a high resolution record because they do not range very far. And their primary predators and agents that are responsible for depositing their remains are owls, and they deposit them through their owl pellets. And they do not range very far from their roost. So for example, the greenhorn owl, they generally range around 4 kilometers from their roost and only 1 kilometer during breeding season. And this has been done before. So the largest and most well-studied small mammal assemblage in the Great Basin actually comes from Homestead Cave in the Bonneville Basin. And other well-studied small mammal assemblages from the Bonneville Basin include Camel's Back Cave and Bonneville Estates Rock Shelter. However, a similar study really hasn't been conducted in the Lahontan Basin. And so here are just some of the small mammals. This is what they would have looked like when they were alive. This is a meadow vole. That is a desert wood rat. And then that's a chisel-toothed kangaroo rat. And then that lovely little gopher with his incisors is a pocket gopher. And so owls, they commonly roost in these caves and rock shelters. And so the same is true for Leonard Rock Shelter. Actually, when we were excavating in 2018 and 2019, there was an owl that was roosting there, but unfortunately every morning when it would see us, it would fly away. But so based on the number of small mammal bones with the bits of fur still adhering to them, we know that most, if not all, of the remains were deposited by these roosting owls. And so using this assemblage, I conducted a faunal analysis to investigate changes in the climate throughout the Holocene. So I based my species identification on crania and mandible morphology and tooth morphology, particularly are these occlusal surfaces. I looked at specimen size and I had to use comparative collections. I took measurements of the tooth rows when needed, and I used plenty of reference manuals. I had to inspect most of these mandibles since they're so small under a 10 to 60 power binocular microscope, and I used number of identified specimens to quantify my findings. And I didn't use any of the small mammals recovered from strata 1 through 3B or from the disturbed deposits from Heizer's Trench. And so that means that this assemblage spans around 11,300 years ago to 4,720 years ago. We know that the lack of substantial late Holocene deposits is due to Heizer's removal of those deposits in our excavation areas. And in addition to this faunal analysis, I also examined Heizer's Leonard Rock Shelter collection at the University of California, Berkeley, and I selected several items for radiocarbon dating. I did so because this sizable collection of fiber artifacts really offered us the best opportunity to address those unresolved questions about when people were actually at this site. And so because our 2018 and 2019 excavations were in Heizer's Area B, I selected 2 pieces of cordage, 1 piece of worked wood, 1 wood fragment, and a feather from that adder dart, all recovered from Area B for dating. And then with the guidance of Dr. Anna Camp from the Nevada State Museum, I also selected several pieces of diagnostic basketry to add to the record of directly dated textiles in Western Nevada. And so these include matting, a sandal fragment, a diagonally twined winnowing tray, which is pictured here, coiled basketry, a cradle basket, and an open twined basket. And so let's talk about the results of the small mammal analysis first. I conducted a multitude of analyses, but just for the purpose of this presentation, I'm going to focus on the abundances and the Shannon-Weaver Diversity Index. So absolute abundances, those are just a count of a certain species in the stratum or just whatever data set you're using. And then the relative abundances, those are just calculating by dividing one species by all the species that occurred within the same stratum or your data set. And so I calculated the absolute and relative abundances of the Townsend pocket gopher, the Bodas pocket gopher, the desert wood rat, and the chisel-toothed kangaroo rat. So Townsend pocket gophers, those are adapted to these deep, wet soils that you can find along the Humboldt River that's just below the rock shelter. And we see that they're present in low numbers in the early Holocene, but they're completely absent after 8,200 years ago. And then if we look at the Bodas pocket gopher, that's a more hot and dry adapted taxon, and they weren't present until the middle Holocene, or till around 5,600 years ago. And actually their absolute abundance was highest in the late Holocene. If we look at desert wood rats, they're also a xeric adapted taxon if their name didn't give it away. And they had relatively consistent but low abundances throughout the entirety of the Leonard Rock Shelter deposits, with their highest abundance actually occurring in the early Holocene. However, interestingly, I identified only one, but I did identify one bushy-tailed wood rat, which is a mesic or cool and moist adapted taxon in the early deposits as well. So that means that the desert wood rat and the bushy-tailed wood rat are kind of coexisting in the early Holocene. And then chisel-toothed kangaroo rats, they're also a xeric adapted taxon, and I identified one chisel-toothed kangaroo rat specimen, roughly half of all strata, spanning the early to late Holocene deposits. However, as you can tell from these numbers, they're really low. So I can't really investigate their individual responses to climate change. So I had to look at the assemblage more broadly. And so that's what led me to the Shannon-Weaver Diversity Index. And so this index, it just measures biodiversity throughout the strata. It's a mathematical measure of species diversity in a community, and diversity indices, they can provide important information about the rarity and the commonness of species in a community, which in this case, it can show us changing environments. So this diversity index, it was the most telling because we see these diversity values, or this H prime on the left, they were pretty high in the early Holocene deposits and even the initial middle Holocene deposits than they were at any time after. It wasn't until the eruption of Mount Mazama, when it deposited that tephra at the shelter, that we see this really pronounced decrease of diversity with this low value of 0.37. And these low diversity values, they continue throughout the middle Holocene with just a slight increase around 5,600 years ago. But we see they're consistently low throughout the initial late Holocene deposits. And the Shannon-Weaver Diversity Index, it can also measure evenness, which is used to investigate changes in the biotic communities through time, but it's really just demonstrating the same pattern as the diversity values on the left. So what did that small mammal analysis tell you? What do those results mean? So let's first talk about the terminal Pleistocene and what the environment was like. The fauna there actually really can't tell us anything because it doesn't date back that far, because we have those beach gravels that are deposited at the shelter. But those in and of themselves are showing us that Leonard Rock Shelter was inundated during the terminal Pleistocene, indicating that lake levels were higher. So this was likely a more mesic time. And then as we move on to the early Holocene, we see that this mesic and xeric adapted fauna are coexisting, suggesting that there was a mosaic of drought-tolerant shad-scale communities and sagebrush steppe within a few kilometers of the rock shelter. And so this variation in vegetation communities, it may have been primarily along an elevational grade, with shad-scale, that more xeric adapted plant, occurring more on the valley floor, and sagebrush, which, believe it or not, is more mesic, occurs more in the West Humboldt range. Or it could have been along the horizontal grade, with sagebrush being more common along the Humboldt River and shad-scale being common elsewhere. So we just see this mosaic of both mesic and xeric adapted plants. And then as we move on to the middle Holocene, we see that the fauna isn't demonstrating these drier conditions after 8,300, where a lot of archaeologists have placed the middle Holocene. These xeric conditions really aren't occurring until 7,600. And we see this in other paleoenvironmental records as well. So at Hidden Cave, we see that there's this consistent sagebrush until around 7,400 years ago. And there was a separate pollen study done at Leonard Rock Shelter, and they discussed this pine minimum, suggesting a more dry time around 7,600 years ago. In the middle Humboldt River, it actually had its driest period beginning at 7,600 years ago. And the Pyramid Lake pollen is suggesting that between 7,600 and 6,300 years ago, it was an especially dry period. And then as we move on to the late Holocene, we see that these low diversity values and the variable species richness in the initial late Holocene deposits are likely demonstrating variable local conditions, but it's really hard to know with such a limited sample because, like I said, Heiser really removed a lot of his late Holocene deposits during their excavations. So now let's move on to the dates that we received on the Leonard Rock Shelter collection that is housed at the University of California, Berkeley. And so, so these dates in green, these all date to the early Holocene or pre-Mesozoic. And then all these ones in yellow, they date to the late Holocene. So you'll see there's a large absence of middle Holocene dates. So these new radiocarbon dates, combined with the radiocarbon dates that we received from our excavations, suggest that people visited the shelter as early as 11,300 years ago and again at 9,500 years ago. They also demonstrate visits between 8,500 and 7,800 years ago, with this hiatus in occupation between 7,700 and 3,000 years ago. And then beginning at 3,000, the date suggests that there were multiple visits to the site, mostly between 2,500 and 1,500 years ago, and one occurred just before Euro-Americans arrived in the region. And so what can those radiocarbon dates tell us about when people were occupying the shelter? Well, like I said, we know people visited the rock shelter as early as 11,300 years ago, and we know that that biface is made up of obsidian of over 180 kilometers away. And so this supports the current models that archaeologists have for this region that says that it's really high mobility and there's an ephemeral nature of visits to sites. People really aren't staying in one place for an extended period of time. And then as we move on to the early to middle Holocene transition, that's where the adult, the cordage, the worked wood, and these olivella shell beads date to. So these olivella shell beads, like I said, they originate along the coast of northern and central California. And so unfortunately, all the olivella beads that the GBPRU found were in disturbed deposits, but Heiser recovered some olivella beads from deposits that could date as back as far as 8,000 years ago. And so if that is indeed the case, then it supports Benioff and Hughes' 1987 argument, where they argued that the Western Great Basin served as a major shell redistribution center beginning as early as 8,000 years ago. And furthermore, it adds to the list of sites that contain early shell beads in the Great Basin. And then as we move on to the middle Holocene, we see that none of the artifacts that we submitted for radiocarbon dating return dates later than 7,700 years ago. However, there is that carbonized basketry that's associated with that infant burial. And so the reason for this really large time range is because this radiocarbon date, it was one of the very first radiocarbon dates we ever had. It was ran in 1950. And back then they didn't have all of those, that fancy technology and those calibration methods that we have today to get those really nice tight time ranges. So they often have these really large errors. So that's why the carbonized basketry can date anywhere between 7,600 and 5,900 years ago. And so it's really hard to know the artifact's true age. So if it dates the early end of the range, then it corresponds roughly with our other directly dated artifacts. However, if it dates the middle or the later end of the range, that's significant because there's currently no other directly dated artifacts between 7,700 and 3,000 years ago. But regardless, this carbonized basketry, it dates the middle Holocene and it makes it somewhat of an outlier. And only Heiser's carbonized basketry date is suggesting that humans visited the shelter during the middle Holocene. And so this fact sets well with studies that have been done in the Western Great Basin. Most notable is Lauterbach et al. 2010 study of radiocarbon date frequencies, which are pointing to a very low human population level at this time in the Lahontan Basin. And so just a conclusion to wrap this all up. What did all of this data mean that I threw at you? So we'll just review the fauna. So the fauna is showing us that in the early Holocene and initial middle Holocene, times were more mesic. These xeric conditions, they really didn't occur until after 7,600 years ago. And based on the fauna at the rock shelter, there's really no marked transition to the initial late Holocene. However, I'm missing a lot of the late Holocene deposits, so I cannot infer too much about late Holocene environments. And then as we move on to the occupation of the shelter, we now know that there's likely no, yeah, there's likely no terminal Pleistocene occupation, but we know that people visited in the early Holocene and at least once during the middle Holocene. And we see that there was relatively heavy use of this site after 3,000 years ago, and it was mostly abandoned after the intensified use of wetlands began 1,500 years ago. Sorry, I kind of skipped that late Holocene portion right there. So like I said, 7 of our recently dated artifacts, they post-date 3000, which is suggesting that was the most intensive occupation time for this site. And so sorry, I just really wanted to dive into why people were visiting the site more between 3000 and 1500 years ago. And so we can look at the Humboldt Lakebed site to kind of know why people are doing this. So the Humboldt Lakebed site, the earliest radiocarbon date we have from this site is around 3,200 years ago, which is roughly the same time that people started using Leonard Rock Shelter more frequently or more intensively. And the Humboldt Lakebed site, it saw increased use 1,300 years ago. And there's a similar story at Stillwater Marsh as well. This site contains a record of human occupation between 3,000 and 650 years ago with increased use at around 1,500. And so these sites are showing that groups began to casually exploit marsh resources and establish these temporary residential occupations around 3,000 years ago. So like other caves and shelters in the area, Leonard Rock Shelter may have seen groups cache their gear during periods when it wasn't needed. However, it differed in one important way. Leonard Rock Shelter lacks tools like duck decoys, nets, fish hooks, and other tools that are clearly tied to marsh resource exploitation. And so this difference may be related to the fact that the rock shelter is located high on the north side of the West Humboldt Range, and it's a considerable and difficult walk from the nearest wetland. And so we see when groups begin to intensify their use of their wetlands, they don't need to visit sites like Leonard Rock Shelter as much. So that's why we see Leonard Rock Shelter is largely abandoned after 1,500 years ago. Sorry, I totally got all mixed up there. So I mostly covered my conclusions already. So we see that after 1,500, people are no longer using Leonard Rock Shelter, although we do have that date that dates to almost the time of Euro-American arrival. So thank you all for hanging in there with me as I totally messed up the end of my presentation. I just want to take a quick moment to acknowledge all of the lovely individuals and organizations on this slide, because this research could not have been done without them. And I would like to particularly thank the Archaeological Conservancy for giving us access to Leonard Rock Shelter and allowing us to excavate this site. So that concludes my presentation.
Thank you, Sara.
No problem. Sorry, I got so mixed up at the end. I don't know why.
You did great. It was very interesting.
I was like, what am I doing? I missed the late Holocene.
Sara, thank you very much for sharing this with us. I learned a lot about your excavations and it was great. So thank you very much for spending your time with us.
Well, thank you for giving us access to the site.
Absolutely.
So it looks like some questions are starting to come in. I've sent you at least one of them already, so I'm going to go ahead and start sending them to you now.
Okay. Oh, the one from Robert Kelly. Okay, so Robert Kelly is asking, it was clearly very useful to return to Leonard. How about Lovelock Cave? Lovelock Cave, it's been excavated a lot throughout the years. It was excavated originally in the early 20th century, back before we had a lot of our modern excavation techniques. So I'm afraid that a lot of the deposits would be disturbed, or that a lot of the artifacts have been removed. But it may be worth going back to see if there are any intact deposits from there, because we did find some at Leonard Rock Shelter. However, Lovelock Cave has just seen a lot more attention, so there may not be any deposits for us to go look at that aren't disturbed. And then there's another one. there's so many questions. Okay. From James Robertson, how are the ancient pollen grains identified? By morphology or DNA barcoding? I believe I didn't do any of the pollen analyses, but I believe they were all done by morphology using comparative collections, much like I would do my small mammals. And then carbonized basketry. That just means it was likely burned, you know, like carbon. So it was just carbonized, it was just burnt, is all that that means. And it was associated, like I said, with that, that infant burial. And then Joseph Sullivan, what about the top of the shelter? Great lookout. Game, question mark? I mean, they likely could have been hunting for game because that's where you find projectile points, is where groups are hunting. So there were 2 projectile points that we found at the site. So they could have been hunting up there, but I'm not sure to what frequency they would have been, because I'm not quite sure what the game routes look like in the Humboldt Sink. And then, did the Mount Mazama eruption contribute to climate change, causing the drier conditions in the Great Basin? Yes, they did. Of course, after Mount Mazama erupted, so if it's depositing this large amount of volcanic ash, it's likely going to not be a really pleasant place to live. It's going to cause a lot of things to die. So that's likely why we see that initial drop in those diversity values, is because a lot of things are dying due to the Mount Mazama eruption. But we do see these low values continuing throughout the Middle Holocene, which is showing that this drier trend is continuing. And then, did I miss any?
I've sent you a barrage of them. I know it's probably a lot to take in.
What reference materials were most useful for your rodent dental examinations? So if you haven't heard, his name's Grayson. He's a very famous archaeologist in the Great Basin, and he is amazing at small mammals. He actually did the Homestead Cave small mammal assemblage. And so I used most of his publications for my small mammal analysis. So I recommend checking out Donald Grayson's publications on his small mammal assemblages. And then of course you have to use a lot of comparative collections as well, because you can't really, you need that for the morphology of them. And then, okay. Why would early residents transport obsidian so far? Is that valuable to transport relatively heavy material? So obsidian is really sharp, and it was a preferred tool stone among early groups, or just groups actually throughout time. Obsidian has been preferred because it's really sharp. However, it does break easily because it is just that volcanic glass. But we see that groups during the early Holocene, they were highly mobile. So 180 kilometers, that may sound like a lot for us today, but it could have just been part of their seasonal round. They probably didn't walk 180 kilometers within a few days. Maybe, you know, they spent the spring here and then winter somewhere else. So 180 kilometers, that was likely a seasonal thing. They wouldn't just pack up and go directly from that obsidian source to Leonard Rock Shelter. Okay. You mentioned pine nut shells. Do you know which species? I do not know what species those pine nut shells were that Heiser found at the during his 1950 excavations. He didn't really dive into the specific species of them. And then Janet Griffin, she asked if the human remains were given to a tribe, and unfortunately those remains have not been repatriated yet. They are still at the University of California, Berkeley, but it is my hope that they will reach out and they will get those remains repatriated to them. That's largely the reason why we didn't really touch Area C during our excavation efforts, or really even our dating efforts, because that's a really sensitive area of the site. So I really, we didn't want to mess with that. And then any books you would recommend about archaeology in the Great Basin. So Donald Grayson, he actually wrote a really great textbook. I think it's called, I'm sorry if I don't get it right, The Natural History of the Great Basin. So it talks both about the environment and the archaeology. So if you really don't know much about the Great Basin, that's a really great place to start. And don't quote me on this, but there may even be a free PDF version out there. Okay. As the lakes dry, okay. Oh, okay, sorry. As the lakes dry, would not salt brine animals become more frequent? So I'm not quite sure what the salt brine animals become more frequent, but animals like chisel-tooth kangaroo rats, those are more attracted to like really salty leaves of like shad scale. And so we do see, as far as small mammals go, those become more frequent during times of drying. But I'm not really, I don't know a lot about other mammals. I only know small mammals, so I'm not sure what other larger mammals were doing during this period. And I take it the basket material from the burial is no longer available for dating. That's just out of respect for the tribe that I didn't request it because I did not feel comfortable doing that. I just don't think that's our place to do that. Okay, did I get all of them?
I think you got the majority of them. I know there was a lot of them, so you may have missed a few in the fray somewhere. In the past, we have, I always give you all the questions so that you can address questions that you didn't get to during the presentation. Later on, we can put them on the website, so I'm happy to send those to you later on as well.
Yeah, that would be great.
Awesome. Well, thank you, Sarah, very much for your presentation tonight.
Yeah, thank you for listening. And again, my apologies for mixing up the end there. That was like the most important part, and I just skipped right over it. So I'm sorry if that ending was confusing. If you have any questions about it, yeah, just feel free to email me or to email the Archaeological Conservancy, and I will answer any of the questions that you have.
Fantastic. I thought it was wonderful. I learned a lot, so.
Good. Good to hear.
Well, thank you everyone for attending our lecture series. This is the last of our spring series, so we'll be back sometime in the summer with something new. So stay tuned.